welcome to Extreme Academy Live Technical Taster. In these short sessions, we're going to give you a free taste of one of the modules from one of our technical tracks. Feel free to ask any questions in the chat. There's someone there to help you. There's also a free downloadable document, so just simply click on the link in the description. Let's get straight to it. Earlier on, Claire caught up with Piotr from VERSIM, one of our authorised training partners. Let's go take a look.
Hello, welcome. How are you?
Very good, thank you very much. How are you?
Yes, very good, thank you. So this is our first technical training taster. Let's just talk a little bit about yourself. So tell me about you. Who do you work for? Go ahead.
Yep. So welcome everybody. I'm working for Polish company, Polish ATP Authorised Training Partner, which is called VERSIM ATP. My name is Piotr, as you can see in the description. It's hard to pronounce probably, so everyone is calling me Peter, which is both international name. I'm working here for many years. Maybe someone says too long, but I'm still happy with that work, and I like to work here. I like to deliver trainings, and my students, I believe they also like that way how I'm doing that. I'm the trainer, and also I'm responsible for the whole team of our trainers and the whole team of our ATP, which operates in almost the whole world actually.
Amazing. So how are you part of a big team? Do you manage a lot of people?
It's still growing. I mean, the team is still growing. At the moment, it consists of 5-6 people. And we are still working on that to make it bigger, because we've got still more and more needs to be covered. Yeah.
Absolutely, amazing. And so you said you're an instructor. Do you specialize in anything?
At the very beginning, because I started my journey with those products with enthusiasts, so a couple of years ago. So at the very beginning, I was specialized with XIQ, formerly known as a net site. But at the moment, I can't say that I've got any specialization here. I like all those products. Most demanding and most popular at the moment are XIQ side engine and fabric solutions. So that's that are my favorite one. Yeah, I may say, and control.
Master of all trades. Some would say. Amazing. So working virtually is quite challenging, I guess. How do you keep your students engaged?
It is sometimes engaged, especially now when we deliver most of the trainings in this remote way. So, the most confusing and most annoying thing for me as a trainer, and I believe that every trainer will share the same opinion, is that moment when you switch your Zoom session and you can see only 12 small black boxes on the screen. So the first thing that I ask people to do at the very beginning when we have this introduction phase is to switch on the cameras and to have a small talk. I believe this is one of the most important moments of the training, of course, regardless of all the technical stuff, because at this stage we may know each other better a little bit, and we may share our experience. We may talk about almost everything. Today I had a training with some people, very nice training, and we've been talking about dogs, and we've been talking about things that people are doing in the free time, playing a guitar, playing drums, whatever. So that's what makes this relationship more, let's say, or soften that. We are not just engineers, we are people. So
we're people. Yeah, I love that. So a reminder to everyone watching: turn on your cameras, basically.
Yeah, usually we don't use the cameras during the whole training, because then it may be a little bit disturbing. But to keep the engagement on the proper level, I'm using different methods of doing that. My whole family is a teacher family, so I think I've got some experience with keeping people engaged with the topics. I'm using tablet. I'm trying to use some additional tools. Also, especially when we talk about cloud or other solutions which are more related to software, I'm trying to show that in the real environment also, to have some real experience. Examples. I've got quite a lot of experience with my customers also. Previously I was working also on the battlefield, so I was involved into this process of delivering that. I'm not just a theoretical trainer. I've got some experience that I can share. And I think that is also quite important.
That helps. Absolutely. All right, well, we'll stop chatting and we'll dive straight in. What is it that you're going to be sharing with us today?
I would like to give you a short sneak peek about that, how I can deliver the Fabric solution training that is a part of installation configuration for Fabric. Basically, this is the last moment of the training, which is delivered on the secondary day of the training. It's gonna be a little bit changed, but it's a VIST, so it's about the cluster, which is built on the edge of the Fabric network.
Brilliant. Okay. Well, whenever you're ready, Piotr, take it away.
Yep. Okay. All right. So let's start the game, and let's talk about the VIST core switch bar, which is a technology offered by the Fabric Connect solution on the edge of the network. It is very important in this case. In case of any network, it is very important to provide a reliable solution on the edge. And the VIST core switch bar is that one which is used to provide the full redundancy on the edge, dual homing on the edge for connected devices, which may be wireless controllers, servers, or other switches, even access points. They may use the dual connection, double connection to the edge to provide redundancy, resilience, and also sometimes to provide a theoretically higher bandwidth on the edge. The objective for this module, the beginning of this module is focusing on the general idea of that. What is aggregation of the links and what kind of aggregation we may use. We'll discuss that how the aggregation is done in case of other systems. Some of the solutions, some of the features will be compared with other systems, like for example Exos devices and VOS devices from Fabric family, and then we'll go to the idea of the cluster, which is involving two devices dual homing on the edge. We'll also identify how link aggregation is implemented on this particular solution. So what steps we need to perform, what steps we need to follow to configure that until the end. We'll talk about this specific VLAN configuration, which is required on SMLT. We'll also talk about in this case I will talk, but usually in the training we talk together, but I usually involve my students in discussion. So those of you who are looking at, please be prepared for some questions also during the training. So I'm usually discuss also that way how the configuration of the switch bar must be done on both devices step by step with commands. At the end of this chapter, there is a short discussion about the proprietary solution, which is available on the VOS/Fabric engine to provide dual homing also on layer 3, so rooted split multi-link trunk RSMLT configuration. So the different type of aggregation which is offered by different devices. The most important fact is that aggregation is used to provide dual homing, redundancy, resilience, and also it is a kind of alternate solution for quite slow and not so efficient spanning tree, which usually would block the connection with if there is a more than one connection toward the same device. Basically, if it's not aggregated, it's going to block. We are going to prevent the blocking. We are going to build a redundancy. In case of VOS devices, in case of Fabric engine, the idea is based on a static approach or dynamic approach. In case of static one, we call it MLT. So MLT, multi-link trunk is used here. So this is the way how we can bundle together up to 8 links. The only requirements here is the links must be of the same speed. So we cannot mix different speed of links here. It is a static approach. So it's not gonna use any dynamic protocols. If you are going to use a dynamic protocols, which is very useful because we then don't rely on any physical connection. Even if someone will unplug cable and plug it to another port, which is also enabled with dynamic approach, with dynamic protocol, then this aggregation will be formed automatically. So LACP protocol, that's what I'm talking about. LACP is based on the standard IEEE 802.1.3 AD nowadays standard, which is based on the link aggregation, which is based on the identification of the both sides. That use the sensor actor ideas to exchange some BPDUs between each others, and if they match on the side, if the BPDU on these ports are coming from the same MAC address here, then the protocol, the LACP, will form the aggregation. But so far, at this moment, we are still talking about one-to-one connection. So this is one switch to one switch, one device to one device, one server to one switch, one access point to one switch. What if we want to provide also redundancy on the level of device? That is not preventing the failure of device. So if something will happen in this case with device, with the switch, that is no connection at all. We will lose the connection, and on the edge, we'll lose the connection to the default gateway, for example. We'll lose the connection from the particular area of the network toward the fabric network. So to prevent that, we may build a dual homing also on the level of the device. So we may also create a so-called VIST in case of fabric engine. This is a solution which you may, or some of you may know also from other vendors, like a Cisco, for example, provide VPSC, virtual port channel, virtual chassis. Like in case of Exos, we've got MLAC solution. That solution of the same idea is also followed by the idea by the solution which is called VIST, virtual inter-switch trunk. Why it's virtual? Because it doesn't need any physical connection between them. Instead of this physical connection, we are going to use fabric infrastructure behind those switches. So that is very efficient solution and very resilient for any problems, any issues. In case of traditional approach, when you gotta just switch to switch connected through the physical link here, that is gonna be a little bit risky, because if there is one connection only, which is of course not the good practice, but if there is only one connection between switches, it's still possible to lose that connection. If you lose the connection between switches, that is going to be a nightmare, because we may go into the problem of the split brain. So two devices using the same MAC address will become as independent devices, and then the traffic will not hit the destination, will not reach the destination, because those two independent devices will still think that they are the only one. So they will not exchange any information. They will not synchronize MAC address database. Nothing will happen, which is designed for the cluster to be work as on a regular basis, right? Of course, we can still build or we can configure that with the multiple ports, which will be also aggregated. So we may use a static aggregation here, which will bring that to the higher level of redundancy, but still it depends on the physical devices. If something will happen with the physical connection between them, then the problem will appear again. The idea of VIST is to use everything which is behind those switches. So the beauty of the whole the Fabric Connect, we are going to use virtual service between them, and there is no need to have any physical connection between those switches, which makes it very efficient and resilient for any problems, which will be shown on the next slide. To build a really resilient architecture, especially when you talk about switch-to-switch connection, we can cooperate between our VIST and other systems, like, for example, MLAC from Exos. So we may have a full connection here. I would even go further. I will even build a full mesh here to provide a full connectivity and the redundancy here that will be really resilient for any issues with the link availability. What is the idea of this SMLT? What is the idea of the VIST? And what are the configuration steps and elements? First of all, we need to configure the VIST as itself. So we need to configure two switches. And the beauty of that solution is that may be any two switches which are part of a fabric. So we may just choose two devices from the edge. It doesn't matter what kind of devices they are. It can be universal hardware and an evolved device. There is no any requirement for those devices to be from the same family of devices, the same type. They may be any devices. So we may just build a cluster from two devices on the edge. And this is the first step. We need to build the VIST. And we've got SMLT ports to be configured. So those ports toward the connected devices must be configured, correctly. First, we need to configure MLT on this device. Then we need to configure MLT on the second device, and then we need to bundle them together by providing correct SMLT identifier for them, and then they will bundle together. They will form the virtual link between each other. What is the result? That device, if I can say that device will think that it's connected only to one single device, because this pair of switches will use virtual MAC address, which is configured on VIST. So all traffic which will pass from there to this will still go to the will still be addressed to the same MAC address, which means that there is no loop. There is no need to use any spanning tree protocol. There is no need to use any loop prevention protocol, because there is no loop. Logically, there is no loop. And that device, from that point of view, it's only configured with particular VLANs. Of course, those VLANs which we want to be reached between those devices and which we want traffic to be forwarded between those two devices, those links must be configured accordingly to that on both sides. Active solution. There is no active, there is no passive, sorry, there is no backup device. Both devices, they actively forward traffic. So we are not going to waste any resources. There is also no any single point of failure, because both devices are still active. They may process traffic. Sub-second failover for most link, switch, down, and up events. It's way faster than spanning tree, even when you consider rapid spanning tree. Split multi-link trunking is used for the link configuration. So all links in a particular SMLT, all links from every device are passing traffic. There is no any link which is prioritized, or any one which is selected as the first one. There is an algorithm which is running over that, and they are more or less equally occupied. It doesn't utilize any spanning tree. There is no spanning tree, so there is no such operation, such a situation that any link will be just simply blocked. But on the other hand, it may happen that your configuration or your SMLT may be misconfigured. In that case, we've got some protocols which are responsible for that, which are responsible for keeping that infrastructure loop-free. We've got the protocols which are SLPP, which are called SLPP. We've got SLPP guard, and we've got also a VLACP protocol, which is used to check the consistency of the whole infrastructure. So we may always be sure that there is no loop, even if something will be misconfigured. That may happen, for example, if someone will just simply unconfigure that device, and that device will be no longer aware of the aggregation here. It will send traffic and will detect a loop. That may happen. So in that case, our SLPP protocol will take care about that. And on the other hand, we've got also VLACP protocol, which is responsible for keeping this efficient, the communication between those elements in an efficient way, by eliminating any faulty links. It may happen that you will have some problem with the optics, for example. One-way communication will happen in that case. It's not a good idea. It's not good for the network, because there is no mechanism which will quickly detect that. But we've got this protocol, VLACP protocol, which is based on sending some probes from any element of the VIST, and this one will keep that loop in a working state. That infrastructure in the working state, and will simply eliminate any faulty links to prevent one-way operation, for example. We sometimes call that, and this is also that what I'm doing. Probably I shouldn't, but I'm using also quite often this terminology, which is called, or this term which is called cluster, switch cluster, because from the logical point of view, those two devices, they work as a cluster of switch, a logical cluster of the switches. Where to use that? I believe that that's quite obvious. It's always on the edge. We will never ever use it inside the network. So there is no technology. There is no. It's not a feature which may be used on a BCBs. It can be used only on a BEB. Just to remind you, BEB stands for Backbone Edge Bridge, in opposite to BCB, which is Backbone Core Bridge. So Backbone Edge Bridges can be configured in a switch cluster pair. And this is always used towards any connected device, which is either a switch or the stack of switches. It can be a server. It can be third-party switch, like a Cisco, for example, because we do support Cisco at the channel. Also, it can be an access point, for example, which is equipped with two Ethernet ports. In case of access points, just make sure that it's a static approach, because there is no LACP supported on the access points in that case. And just to give you the sneak peek about this resilience, I told you that, and I told you that it will be explained a little bit later. The resiliency is really better, way better than just the resiliency which can be offered by a single physical link. Instead of using a single physical link between backbone edge bridges, which are forming a cluster here, once again, I use the cluster, sorry, in a VIST solution. Instead of that link, which can be still used, of course, but instead of using just one single link, we use the whole infrastructure. So if anything happened here, so we are going to lose that link, ISIS protocol with SPBM will find another also very good path to the destination, the next one, which may cross through the additional node. If that link is broken, if we are going to lose that one, still, if there is any other path, the connection will be not interrupted, because ISIS, together with SPBM, they will immediately find the next way because of the feature of the Fabric Connect, which is self-healing in that case. So if there is any path, the VIST will still remain active. And that is what I mentioned previously. The resiliency here is a way higher than in case of using just a single physical link right here. We are going to use a virtual IST. We are going to use a virtual IST ICIT, specially created, and that's only used for that, to let them communicate with each other. This ICIT is used to send and synchronize a MAC address table between those BBs to be ready to answer for any requests which may come on this or on that link. This is the way how VIST works, and this is the way how the VIST can offer higher resiliency than other solutions which we may know from traditional networking. And also, of course, this is the beauty of Fabric. I think we are not going to continue any longer. More about the Fabric and more about cluster I will be delivered on the regular class. And I hope that gave you a kind of sneak peek of that, what you may expect on my course.
That was brilliant. I hope you all enjoyed that. And thank you so much, Piotr, for your time and that short taster in Fabric installation and configuration. If you liked what you saw, we've got many more Extreme Academy live sessions to come. So make sure you're following us on LinkedIn and you'll be the first to hear about when they're all happening. Don't forget, if you want access to the slides that Piotr presented, simply click on the link below and you'll have access to those. And if you want to find out more about our training, both professional and associate, you can find all the information you need on our website. Alternatively, if you've got any questions, drop us an email. But that's all for now. We hope to see you next time. Take care.